A company manufactures two products X and Y by using three machines A, B, and C. Machine A has 4 hours of capacity available during the coming week. Similarly, the available capacity of machines B and C during the coming week is 24 hours and 35 hours respectively. 1 unit of product X requires 1 hours of machine A, 3 hours of machine B, and 10 hours of machine C. Similarly, 1 unit of product Y requires 1 hour, 8 hours, and 7 hours of machine A, B, and C respectively. When 1 unit of X is sold in the market, it yields a profit of $5 per product, and that of Y is $7 per unit. Solve the problem by using graphical method to find the optimal product mix. Let us start our solution by interpreting the question. We have a company manufactures 2 products X and Y. So the products that the companies manufacture are what? X and Y. That is why I put down here products are what? X and Y. Using 3 different machines, which are what? Machine A, machine B, and machine C. That's why I put it down here. The machines that the company used to manufacture products A, B, and C are machine A, machine B, and machine C. Okay, let us proceed. Machine A has 4 hours of capacity available during the coming week. So the hours of capacity that machine A has is 4. So I put 4 in this place. Similarly, the available capacity of machine B and machine C during the coming week is 24 hours and 35 hours respectively. So the hours of capacity of each machine, for machine A it is 4, for machine B it is 24, and for machine C is 35. Okay, let us proceed to the next statement. 1 unit of product X requires 1 hours of machine A, 3 hours of machine B, and 10 hours of machine C. So I interpret it as this. To produce 1 unit of X, the company is going to use 1 hour of machine A, 3 hours of machine B, and 10 hours of machine C. You understand? So let's proceed to the next statement. Similarly, 1 unit of product Y requires 1 hour, 8 hours, and 7 hours of machine A, B, and C respectively. This is the interpretation of that statement. To produce 1 unit of product Y, the company is going to use 1 hour of product A, 1 hour of machine A, 8 hours of machine B, and 7 hours of machine C. Okay, when 1 unit of X is sold in the market, it yields a profit of $5 per product. That is, when the company sold out 1 unit of product X, the revenue that they're going to get is $5. And that of Y is $7 per unit. When a unit of product Y is being sold in the market, the profit that the company is going to earn is $7. Now, having interpreted the question, let us proceed to formulate the table.
Okay, here are the given parameters from the question. Now let us start by providing a linear programming table for these parameters. Here, the first parameters that was given in the question is product X and Y. So I'm going to have products. I want to construct linear programming table now. Products X and Y. Okay. Another one is the machines. So I'm going to have machine A, B, and C. Okay, hours of each machine, that is the capacity of each machine in hours. So for A, the capacity is 4. So another parameters will be here, hours or available capacity, anything that you can call it. Let me call it available capacity. Okay, available capacity. So for machine A, the available capacity is 4 hours. So I'm going to trace it downward. I'm going to trace it right forward. So I'm going to have 4 in this place. For capacity B, for machine B, the capacity is 24. So I'm going to trace B to the right. So this will be what? 24. So for machine C, the capacity is 35. So I'm going to trace it. This will be 35. You understand? Okay. Now, I want you to note the fourth parameter. The fourth statement, which is to produce 1 unit of X, we need 1 unit 1 hours of machine A. So to produce 1 unit of X, I need 1 hours of machine A. So I'm going to have 1 here. To produce 1 unit of X, I also need 3 hours of machine B. So I'm going to have 3 here. Note that all these are under the product X. Are you getting it? So let's proceed. And also to produce 1 unit of X, I still need 10 hours of machine C. So I'm going to have 10 in this place. You understand? So let's proceed to the fourth, 1, 2, 3, 4, 5. The fifth statement, which is to produce 1 unit of Y. We have to make, the company has to make use of what? 1 hours of machine A. Don't forget that this is also 1 hours of machine A to produce 1 unit of Y. Okay. And also, the company need 8 hours of machine B. So I'm going to have 8 in this place. 8. To produce 1 unit of Y, the company still needs what? 7 hours of machine C. So I'm going to have 7 in this place. The profit that the company realized by selling 1 unit of X is what? $5. So let me have another parameters in this place, which is what? Profit. So for X is what? $5. And the profit that the company realized by selling 1 unit of Y is $7. So I'm going to have 7 in this place. Okay. Now you can see that we have completed this table. The next step is to now formulate the inequality. That is the objective function and the constraint. You understand? We have to formulate the objective function and the constraint because linear programming comprises of objective function and constraint. Okay, please. Now, having drawn out our table, the next step is to formulate the inequality equation. That is the objective function and the constraint. Now, before we can formulate the objective function and the constraint, we have to know the unit of product X and product Y that the company will produce. So I'm going to represent those units as small letter X and small letter Y. So let the total unit of X produce, the total unit of X, the total unit of X, total unit of X produce, let it be what? Small letter X, small letter X. And the total unit of Y, the total unit of Y, the total unit of Y produce, let it be equals to small letter Y. You understand? Having represented the total unit of X produced and the total unit of Y produced by the company as small letter X and Y. Now, let's start by forming our objective function. The objective function is also known as the profit maximization function. And as you can see from the question, the profit that is gotten by selling out 1 unit of X is $5, and the profit that is gotten by selling out 1 unit of Y is $7. So I'm going to have, for the objective function, let me call it max Z is equals to, objective function is 5x plus 7y. So this is the objective function. You understand? This is the objective function. That is, immediately I know the amount of product X that the company produce, I can get the total profit by using this equation. You understand what I'm saying? So now let us proceed to form the constraints. Objective function in linear programming will be subjected to constraints. You understand what I'm saying? So let me call it subject to. Okay, the first constraint is what? The machine A. You understand what I'm saying? The first constraint is machine A, because assuming the machine is limited, that the machine is limited in capacity. The capacity of machine A is 4. Machine A cannot expand beyond 4. You understand what I'm saying? We cannot use machine A beyond 4 hours. You understand what I'm saying? So the first constraint is what? Machine A. And to form the inequality equation of this first constraint, we are going to make use of the same approach. For machine A, to produce 1 unit of X, we have to make use of 1 hours of machine A. So I'm going to have 1x plus, to produce 1 unit of machine A, and to produce 1 unit of product Y, I have to make use of what? 1 hours of machine A again. So I'm still going to have 1y is less than or equals to what? 4. You understand what I'm saying? Is less than or equals to 4. This is the first constraint. Please, I want you to follow me carefully. Okay, the next constraint is machine B. Machine B cannot be used beyond 24 hours. You understand what I'm saying? So the machine has constraint. It has limited the amount of products X and Y that we can produce. So the second constraint is also what? Machine B. Now let us form the inequality equation. So to produce 1 unit of product X, I will need 3 hours of machine B. So I'm going to have 3x plus to produce 1 unit of machine Y to produce 1 unit of product Y. I'm still going to use 8 hours of machine B. So I'm going to have 8y is less than or equals to what? 24. So I'm going to have 24 in this place. Okay, let us move to the third constraint. The third constraint is what? Machine C. You understand what I'm saying? The third constraint is machine C because we cannot expand, we cannot use machine C beyond what? 35 hours. You get what I'm saying? The hours of capacity has limits our production. So it has constrained us from producing more. So the third constraint is machine C. So to produce 1 unit of product X, I still need to make use of what? 10 hours of machine C. So I'm going to have 10x plus 7y is less than or equals to 35. You get what I'm saying? 35. So I have gotten the objective function and the constraint. Since I cannot draw an inequalities on the graph, I have to make this objective function and the constraint an equation. So the objective function becomes z is equals to 5x plus 7y, and the constraint becomes 1x plus 1y is equals to 4. I have made this an equation, and for this 3x plus 8y is equals to 24. Then 10x plus 7y is equals to what? 35. So I have made the objective function and the constraint an equation by changing the inequality sign to what? Equals to sign. So now let us proceed to solve. Okay, don't forget that the coupling is constrained by the machines. You get what I'm saying? So the first constraint is for machine A. You understand? Machine A. The second constraint is for machine B. You understand what I'm saying? Machine B. And the third constraint is what? Machine C. Are you getting what I'm saying? So now, before we can proceed with our solution, we have to find the zeros of each constraint. How do we find the zeros of each constraint? Let's start for constraint 1, which is for machine A. And the equation is what? 1x plus 1y is equals to 4. To find the zeros of this constraint, we have to assume that the company is not producing any product of machine Y. That's the first thing. We have to assume that the company is not producing any product of machine Y. Then we are going to find the amount of product of machine X that the company can produce by not producing any product of machine Y. So I'm going to set Y is equals to 0. So I'm going to have when Y is equals to 0, I'm going to have 1x. The equation becomes like this. 1 into bracket 0 is equals to 4. So 1x is also the same thing as x. X is equals to what? 4. When the company is not producing any product of Y, the total amount of product that the company can produce using machine A is what? 4. Are you getting it? Okay, let's proceed. Now let's assume that the company is not producing any product of machine X. In that case, we are going to set X is equals to 0. So I'm going to have the same equation. I'm going to have when x is equals to what? 0. I'm going to have 1 into bracket 0 plus 1y is equals to 4. Make y the subject of the relation. So I'm going to have y is equals to what? 4. Because 1 multiplied by 0 is 0. 1y is also the same thing as y. So y is equals to 4. So the amount of product y that the company can produce when the company is not producing product X is what? 4. You understand what I'm saying? That is the total amount of product Y that the company can produce if the company does not wish to produce product X is what? 4. So I have gotten the zeros are what? x comma y, that is what? 4 comma 4. Okay, keep this. Let's proceed to the second constraint. Let's find the zeros of the second constraint. Okay, I just rewrite the constraint and the objective function to this side so that I can make use of this space. You get it? So I've not done anything. Now let us proceed to find the zeros of constraint 2, which is for machine 2. Now we are still going to use the same approach. The second constraint is what? 3x plus 8y is equals to 24. Now let's assume that the company is not producing any product of y. You get what I'm saying? It's not producing any unit of product y. So I'm going to set y is equals to what? 0. So I'm going to get the value of x when y is equals to 0. That's the summary of what I'm saying. Okay, so set y when y is equals to 0. The equation becomes like this: 3x plus 8 into bracket 0 is equals to 24. So 3x is equals to 24. X is equals to what? 24 divided by 3, that is what? 8. Okay, now we are still going to set x is equals to what? 0 to get the value of y. You get it? That is, we are assuming that the company is not producing any unit of product x. So I'm going to say when x is equals to what? 0. The equation becomes like this: 3 into bracket what? 0 plus 8y is equals to 24. So I'm going to have 8y is equals to 24. Y is equals to 24 divided by 8. Y is equals to what? 3. So the zeros of this x comma y is what? 8 comma 3. Do you understand? Yeah. Let's proceed to the third constraint. Don't forget that the third constraint is what? Machine 3. Okay, the equation is what? The equation is 10x plus 7y is equals to what? 35. Okay, now let's assume that the company is not producing any unit of product y. So I'm going to set y when y is equals to 0. So I'm going to have 10x plus 7 into bracket 0 is equals to what? 35. So 10x is equals to 35. X is equals to 10 divided by 35, that is 3.5. So x is what? 3.5. And when y, let's assume that is, we assume that the company is not producing any unit of product x or machine 3. You get what I'm saying? So we are going to have 10 into bracket 0 plus 7y is equals to what? 35. So 10 multiplied by 0 is what? 0. So I'm going to have 7y is equals to what? 35. Y is equals to 35 divided by 7, that is 5. So the zeros of 10x plus 7y is equals to 35 is what? X comma y, that is, x is 3.5. So I'm going to have 3.5 comma 5. You get it? Okay. Now, having gotten the point, we have gotten our point, which is point x comma y. Point x comma y for first constraint is what? 4 comma 4. For the second constraint is what? 8 comma 3. For the third constraint is what? 3.5 comma 5. Now, it is this point that we are going to plot on our graph. Are you getting it? Okay, this is my graph. I have coordinate y. This is for y. And this is for what? X. Okay. Now, let us proceed to plot the coordinate that we have from our constraint. Let us proceed to plot it on this graph. For the first coordinate, I have 4 comma 4. That is x comma y. So I'm going to locate 4 from the point x and 4 from on the graph of y, on the line y. Okay. So I'm going to rule it. Sorry, I'm not good. My hand is not straight. Please just make sure that you get what I'm saying. You get it. Okay, let's proceed to plot the second coordinate. We have 8 comma 3. Okay, the first is 8. I'm going to locate 8 on the x-axis and 3 on the y-axis. So I'm going to have this. Now I'm going to draw a line right from the x and y-axis down to the x-axis. You get it? That is for coordinates 8 comma what? 3. Now the last coordinate, which is 3.5 comma 5. For x, I'm going to locate 3.5, and if you look, since 3 is there and this is 4, 3.5 will be the middle of 3 and 4. You get it? So and on the y-axis I'm going to locate 5. So I'm going to locate this place, and I'm going to rule a line from the y-axis. This is 3.5. So 3.5. So I have plotted each coordinate. I have plotted it on this graph. For the first coordinate, this is 4, 4, this line, and the next one is 8, 3, which is what? 8, 3, and the last one is what? 3.5, 5. Okay, now I want you to pay attention in this place. This graph shows the visible region for all the constraints. And don't forget that when I talk about the constraint of the complaint is the hours of the capacity of each machine. So this graph shows the visible region of each of this machine. So you can see that this shape forms a polygon. For this place, let me call this A. Let me call this point B. This is point C. This is point D. This is point E. This implies that all the points on polygon A, B, C, D, E satisfy the inequality equation of these machines. You get what I'm saying? So now let us get the points. For the point A is what? Point A, let's trace it. Point A is 3, 0. You get it? Oh, 0, 3, because we have to mention, when we are talking about coordinates, we are talking about x and y. We have to make reference to x first before y. You get what I'm saying? So when at point A, the value of x is what? 0. You get it? And the value of y is what? 3. So point A is what? 0, 3. Okay, at point B, the value of x and y is what? 0, 0. At point B, that is 0, 0. So at point C, the value of x, y is what? X is what? 3.5, and y is what? 0. So at point C, the value is 3.5, 0. Please, are you getting what I'm saying? Are you getting what I'm getting the point? I'm only making reference to what? Polygon A, B, C, D, and E, and I'm checking the points. I'm making reference to the point which they lies on x, y coordinates. That's what I'm doing. You get what I'm saying? So for point C now, the value of x is 3.5, and the value of y is what? 0. That is why I have point C 3.5, 0. Please, are you getting it? Okay. At point D, okay, from this point, this is point D, I will have to trace it downward to get the value of x. So, and if you look at this is 2. This region will be what? 2.5. So this will be greater than 2.5, maybe like 2.7. So the value of x is 2.7, please, are you following? So I'm going to trace point D to the y-axis also to get the value of y at that point. So I'm going to have, let me trace it. Okay, you can see this is 1, so it is above 1. That is 1.4, because if this is 1, this region will be what? 1.5. So this is 1.4. So at point B, the value of y is what? 1.4. You get it? Okay, let us get the value of x, y at point E. Are you getting it, please? So let me put it down here. E, at point E, this is point E. So I have to trace it downward to the x-axis. You can see the value of x is what? If this is 1, this is 1.5, this region is 1.5, this is above, this is beyond 1.5, so the value of this place will be 1.7. So at point E, the value of x is 1.7, now I'm going to trace this coordinate, I'm going to trace its point to the y-axis to get the value of y at that point. So I'm going to have, okay, since this is 2, this is almost 2.5, because this region will be what? 2.5. So this is 2.4. 2.4. Okay, now I have gotten the coordinates. I have gotten the points from this polygon A, B, C, D, and E. And don't forget what I said earlier. I told you that this polygon A, B, C, D, E, and E shows the visible solution for this machine, for this constraint. Are you getting what I'm saying? Now, that means that the value of x and y at that point satisfy all the inequalities, satisfy all the equation. So I'm going to substitute all this value into my objective function. Are you following? I'm going to substitute all the value into the profit maximization function. The objective function is also known as the profit maximization function. Now let us substitute. So I have for z 0,3, the objective function for 0,3 becomes, the objective function is 5x plus 7y. So I'm going to have 5 into bracket 0 plus 7 into bracket what? 3. That is what? $21. Don't forget that they gave us that the revenue gotten from the product, from selling the product of X and Y is in dollars. So that's why I put dollar here. That is $21 for 0,0, that is 5 into bracket what? 0 plus 7 into bracket what? 0. That is what? $0. That is $0. For point C, I have Z into bracket 3.5, 0. That is 5 into bracket what? 3.5 plus 7 into bracket what? 0. 5 multiplied by 3.5, that gives me 7.5. So this one will be what? $7.5. Okay, for point D, Z 2.7, 1.4. That is 5 into bracket what? 2.7 plus 7 into bracket what? 1.4. 5 multiplied by 2.7. That is 13.5. 13.5 plus 7 times 1.4. That is 9.8. 13.5 plus 9.8. 23.3. So the value for this is what? $23.3. You get it? So let's proceed to the fifth coordinate. That is z 1.7, 2.4. So I'm going to have 5 multiplied by 1.7 plus 7 multiplied by 2.4. Okay, 5 multiplied by 1.7, that is 8.5. 8.5 plus 7 multiplied by 2.4, that is 16.8. 16.8. Now add this together, you are going to get 25.3. So the value for this is $25.3. You get it? So now don't forget that this is for point A, this is for point B, this is for point C, this is for point D, and this is for what? Point E. Since this linear programming problem is a maximization problem, hence we have to choose a value that will maximize the profit of the company. And if you look at this, the maximum value is what? $25.3. Hence, for the company to maximize its profit, it has to produce 1.7 units of X and 2.4 units of Y. Therefore, the optimal solution for this linear programming problem is that the company has to produce 1.7 units of X and 2.4 units of Y for it to maximize a maximum revenue of $25.3. Thank you very much for watching the video. Please, I would like you to subscribe to this channel and hit the notification bell so that when I drop new video, you are going to get updates. Thank you.